I'm Hannah. I'm a tutor at Sky Academy, and we're in the topic of measurement within the Year 11 standard course. And we're looking at perimeter, area, and volume, which comes under MSM1. So in this video, we're going to have a look at the trapezoidal rule. So the trapezoidal rule is similar to finding the area of a trapezium. It has same principles, but it's a little different. So we use the trapezoidal rule when we're trying to find the area of an irregular boundary. So instead of having a set boundary that goes straight across the top like a trapezium, this one is irregular. So we use this method of taking what's up here and pretending it fills in this area here to get the area of this shape. So it's giving an estimation of what it could be like if we take this top part, the extra top part, and move it over to the bottom part, which is missing a little bit. Then hopefully it will even it out and we'll be able to find the area of that shape. So the trapezoidal rule is an estimation for an irregular boundary. So it could be, for example, the boundary of a lake. So we have grass in this rectangle here, and then we have a little pond, and it goes like this. And it's an irregular boundary, and we have been asked to find the area of the grass and the pond combined. So that's what the trapezoidal rule is. The shapes that you'll get for the trapezoidal rule look like this one below, with a flat base, two sides, and then the curved irregular boundary. So the formula for the trapezoidal rule is where A, the area, equals h on 2. So it's the width between the two sides, or the parallel, the distance between the two parallel heights. The distance of the first parallel side and the distance of the last parallel side. It's the difference between the two, and or the base. So the area equals h, or the width between the sides, on 2 times by the distance of the first side, so from here to here, plus the distance of the last side. So let's have a go at doing some examples. So here it says, use the trapezoidal rule to estimate the area of the field shown. So firstly, we need to write down our formula for the trapezoidal rule. So now we've got the trapezoidal rule formula, we can sub in what we do know and solve for what we don't know. So our area is going to equal h on 2. We know that the base, or the distance between the two long parallel sides, is our h. So that's going to be our h there. So our h is 18 on 2. Then the distance of the first is going to be here, the distance of the first parallel side, and the distance of the last parallel side will be 35. So 26 plus 35. And now we can simply put that into our calculator to solve. So 18 on 2 times by the distance of the first plus the distance of the last gives us 549 meters squared. So the trapezoidal rule is quite easy to apply. You just have to remember the rule and then sub in what you do know and solve for what you don't know. And in this case, we didn't know the area, so that's what we were trying to find. So let's have a go at doing another example of the trapezoidal rule, but this time we're going to use 2 applications. So it says use the trapezoidal rule twice to estimate the area of ABCD to the nearest square centimetre. So we're going to use 2 applications instead of just 1. So you can actually use as many applications of the trapezoidal rule as you need to. The question in your exam might ask you to do 4 applications of the trapezoidal rule, and that's fine. You just have to remember and get the distances of your first and your last parallel sides correct. So our first application of the trapezoidal rule will be for section 1. So our area is going to equal h on 2 times by distance of the first plus distance of the last. So our area is going to be h, which is represented here by the long line, but 36 is the distance from D to C. If we're breaking it up into 2 sections, we need to break that up into 2 as well. So 36 divided by 2 is 18. So our first h is going to be 18 here, and our second one will be 18 there. So just remember, if they didn't write in the 18s for you, then you'd have to remember that because you're breaking it up into 2 sections, you also have to break up the width between the parallel sides into 2. So we have 18 on 2 times by the distance of the first, which for us is going to be 22, plus the distance of the last, which is for section 1, 60. So for section 1, ignore section 2, and the first parallel side is A, which is 22, and the second parallel side is here, which is 60. And section 1 is enclosed in between these 2 sides. So let's put that into the calculator. So we get 18 on 2 times by 22 plus 60, and we get 738 centimeters squared. So now let's have a go at doing our second application of the trapezoidal rule. So we still are going to use that same formula, so I'm not going to write it out again, but we have area equals 18 on 2 because our height or our distance between the parallel sides doesn't change. Then we're going to times it by the distance of the first plus the distance of the last. This time when we're looking at section 2, the distance of the first is going to be 60. So ignore section 1, and the first side that makes up the boundary of section 2 is 60. And then we're going to plus that with the boundary of the distance of the last side, which is 48. And that means section 2 will be enclosed in between these 2 sides. And when you put that into your calculator, you should get the answer of 972 centimeters squared. So therefore, if we add section 1 to section 2, it will give us the total for this entire shape, which is the shape of A, B, C, D. So 972 plus 738 gives us 1,710 centimeters squared. So that's how you do applications of the trapezoidal rule. You just use the formula, which is h, which is the distance between the parallel sides, on 2 plus the distance of the first parallel side plus the distance of the last parallel side. And once you have got your formula, you sub in information into the formula to solve for the area.